Hello and welcome to my kitchen. So today I'm going to show you a little bit about what I do when I bake. Actually, this is more statistical in nature than I usually get when I'm baking, but baking is one of my favorite things, and so I figured I'd bring it into my kitchen. So today what we're going to be doing is we're going to be talking about a recipe that I just tried the other day called horchata French toast. So let me kind of show you a little bit. So this recipe's in one of my favorite cookbooks. It's More Mexican Every Day by Rick Bayless. And in it, he's got a recipe for horchata French toast. And the crazy thing about this horchata French toast is that it calls for a 2-inch piece of cinnamon stick. It calls for a 2-inch piece of cinnamon stick, preferably Mexican canela broken up, or some ground cinnamon, or so on and so forth. So I was at Honeybee Market the other day, and I actually did pick up some cinnamon. I got a whole bunch of cinnamon for Honeybee, and one of the things that I'm kind of wondering when I'm looking at this recipe is how long are most cinnamon sticks? And so that's the statistics that I kind of want to get into today is how do you figure out how long most cinnamon sticks are? Because I need a 2-inch piece of cinnamon stick for my horchata French toast. So to figure out how long a piece of cinnamon is, we could just start measuring. I'm going to grab some cinnamon out of the bag and measure it. I'm going to measure it to the nearest inch. And then I'm going to write down my measurements on the screen here. So let's start with this bad boy. This is a gigantic cinnamon stick. Let's see how big it is. So this cinnamon stick right here is 11 inches. So let me write down that one. Here's another one, another nice big one. This one is 10 inches. And we've got one that is 7. And we've got another 10. And we've got a 9-incher. And a 3. And a 2. And another 3. And a 2 and a 2. And I've got 7. And a 6. And I've got a 4. And I've got another 2. So how many have I got so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's go for another one. And I've got another 2. All right, so this is the measurement of the cinnamon sticks that I've just taken. I've taken a nice sample out of the bag. And from this sample, those are the measurements that I got. So I just did collect data. One of the things you might be wondering is what type of sample this is. In this particular instance, I still have a bag left of more cinnamon sticks. I have not taken them all out, so I would say this is a convenient sample. I've reached into the bag, I've grabbed the easy to reach cinnamon, and I've pulled it out. So, nice convenient sample. When I look at my data, it's a little bit difficult to still say how large these pieces of cinnamon are. You see that there are a bunch of 2s, but how do I know how big cinnamon is in general? One way to figure out how big cinnamon is to look at what we call measures of center. Measures of center are supposed to be kind of like those measurements that are somewhat in the middle of our data. So one measure of center is the sample mean. To get the sample mean, some people call it average. What we've got to do is we have to add them all up and then divide by the number of values. So here we've got 15 values. I have placed them in order. And from those values, if I add them all up and divide by the 15, that gives me the sample mean. So in this case, we're talking about taking And to represent sample mean, I'm going to put an X with a little bar on top of it. Sometimes we call it X bar. And we're going to set that equal to the sum of all these guys. So I'm just going to add them all up. Divided by 15. And if you look at this, we get 80 divided by 15, which is 5.3. It's 5.3 repeating, so you can do it like that, or you can put 5.3. Some people like to put a bar above the 3 to say that that's the repeating digit. Or you can round it to the nearest tenth or hundredth, depending on what we ask you to round it to. This kind of a nice number. It gives me a feeling for about how long these cinnamon sticks are. Now notice that no cinnamon stick was 5 inches. So it's not the greatest number per se, but it does give me a good rounded figure as far as like some of them are small, some of them are large, and so on and so forth. So if you're not happy with the mean, there is another measure of center, which is called the sample median. The median is the middle number when the numbers are placed in order from smallest to largest. So in this case, we've got 2 would be the first number, 2 would be the second number, the third number, the fourth number, and the fifth number. 3 would be the sixth number, 3 would be the seventh number, 4 would be the eighth number, 6 would be the ninth, 7 is 10, 7 is 11, 9 is 12, 10 is 13, 10 is 14, and 11 is 15. Now the middle number is that number that's in the very center. So if I go up 8, so 1, 2, 3, 4, 5, 6, 7, 8, the 8th number is 4. And if I count backwards 8, from 15 would be 1, 14, 2, 13, 3, 9, 4. So if I count backwards 8 from 11, 1, 2, 3, 4, 5, 6, 7, 8, I also land on this 4. So in this particular instance, 4 is the median. So the median is that middle number when placed in order from smallest to largest. And the last number is the mode. The mode is the number that occurs the most. And the number that occurs the most here is 2. 2 occurs five times. So the mode in this particular instance is 2. These numbers are supposed to give us a feeling for how long the cinnamon is. I mean, obviously, if I wanted to, if somebody called me up right now and said, hey, are you making that French toast too? You are? And then they asked me how long my cinnamon was, I could say, well, I've got a stick that's 2 inches, 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 a stick that's 3 inches, a stick that's 3 inches, and keep on going all the way through the list. Or these measures of center give you a good feeling. I could say, well, the average length of my cinnamon is about 5.3 inches. That gives me a feeling for most cinnamon is somewhere around 5.3 inches. Or I could say the mode is 2 inches. That gives you the feeling that I have a lot of 2-inch pieces of cinnamon. Or the median is 4 inches. Half of the cinnamon is bigger than 4 inches and half of the cinnamon is smaller than 4 inches. So it gives you this feeling for how big the cinnamon is in general. So with that being said, we've got 3 different measures of center that are able to kind of approximate how big the cinnamon is. One thing to mention before moving on to the next slide is that these are for sample mean, sample median, and sample mode, these calculations we did, because we did a sample. The population mean is the actual mean for the entire population. And we denote it with a Greek letter mu. So it kind of looks like a fun-looking M. You could ask, so these are examples of statistics because they're related to the sample. So my statistics for this sample are the mean of 5.3, the median of 4, and the mode of 2. One of the things you could certainly ask is this sample representative of the population? And if you remember from earlier, I took a convenience sample, and it's nowhere close. Why is it not close? Because conveniently, it was easiest to pull the biggest pieces out of the bag first, before moving on to the smaller pieces in the bag. If you were to be right here and look, the rest of the bag is all fairly small pieces. And these small pieces look like they range anywhere from 1/2 inch to 4 inches. And there's tons of them left over in this bag. Which means that really my average for this bag is probably closer to about 3 inches. But I'm getting a gigantic average because I did a convenient sample. So this is one example where the convenience sample gives me biased results. So this is not the only cinnamon that I have in my house. I've got other cinnamon as well. And we can play the same game and kind of see what happens when we look at the other cinnamon. So this cinnamon here is from Trader Joe's. It comes in a nice little jar. And what I'm going to do is I'm going to take this cinnamon and I'm going to measure it to the nearest quarter of an inch. So it's either going to be 1 quarter, 2 quarters, 3 quarters, or 4 quarters. So it's either going to be 0.25, 0.5, 0.75, or 0.0. So let's start measuring. I've got a 2.75. I've got another 2.75. And I've got another 2.75. And I've got another 2.75. Oh, and I got a small one. I got a 2.5. Now, reason being, this is a harder cinnamon, and they need it to fit in the jar. So why not cut it to just less than 3 inches, and it will fit in the jar. You could play the same game with these numbers. With these numbers, we've got a mean. So if I take these up and I add them all, I'm going to add them up. When I add the 2.75, the 2.75, and so on and so forth, I get 16.25. And there are 6 measurements. And so what I end up getting is I get 2.71 as the mean, if I round it to the nearest hundredth. For the median, I'm going to have to put these in order. So let's change this first number to the 2.5 and change this last number to the 2.75. Wow, now the numbers are in order. So what I end up having is, oops, there's supposed to be another 2.75 in there that I said and forgot to write down. So when I'm looking at this and I count to the middle, what I end up getting is I've got that the middle number, there are actually 2 middle numbers, 2.75 and 2.75. So what's the middle number? Well, the middle number should be the average of those 2 numbers. So in other words, I'm going to add up those 2 numbers, 2.75 plus 2.75, and I'm going to take their average and I'm going to divide by 2, or take the mean. And so what I end up getting is I get 5.5 divided by 2, which is equal to 2.75. So anytime you're taking the median, if you have an odd number of pieces of data, what's going to end up happening is you will have a middle number. And so you can actually find that middle number, and that is your median. But if you have an even number of numbers, then there is no middle number. It's in between 2 numbers. So find the in between. Add up those 2 middle numbers and divide by 2. And that's like the halfway point in between those. And lastly, my mode for this particular example is 2.75. That occurs 5 times. In fact, you'd almost have to write to Trader Joe's and ask them why they put a 2.5-inch piece of cinnamon into what is clearly supposed to be 2.75-inch cinnamon sticks. But who would do that? And I'm sure that it doesn't say anywhere on the jar it's supposed to be like that. But that's fine. The last thing I want to talk about is where the mode, the mean, and the median show up on the distribution, on the histogram. The mode shows up as the tallest peak. It happens the most often, so its peak is going to be the tallest. The mean, well, before we talk about the mean, it's easier to describe where the median is. The median is the point where half of the data is on one side and half of the data is on the other side. So if you were to shade in the regions below the median and the region above the median, what you'd end up having is it would take half of the color or the paint, if you were to paint it in, half of it would be on one side and half of it would be on the other side. The area is equal on both sides. The mean, and with relation to the median, is going to be pulled towards the tail. So if it is left skewed, or some people call it negatively skewed, the mean will be pulled towards that left side, and so it will be on the left-hand side of the median. If it is right skewed, the mean will be on the right-hand side of the median. Now what ends up happening is, because of these skews, it's kind of like having outliers, or the data is kind of skewed, I guess. And so in some situations, it would be best to use the mode, some situations the mean, some situations the median. The mode is really best for qualitative data. If you're looking for what color hair people have, if you find one color that happens the most, maybe it's purple, then the mode, purple hair, would clearly be the best way to describe the data that you got. More people had purple hair than any other color hair. The mean is best for data that's not skewed or have any outliers, which means that the mean and the median would pretty much be the same. The median is best when quantitative data contains outliers or is skewed. So it's going to be a nice way to represent the data if you're looking for measures of center. One of the things they just said was that the mean and the median would typically be the same if your data is not skewed or contains no outliers. And the reason that we would still look to use the mean or the median is because you're not always going to draw the graph. But it's easy to see when data has outliers. They're numbers that are sitting way above the rest of them. In our example with the cinnamon sticks, we had a couple cinnamon sticks that were 10, 11, 9 inches. They were way above most of the other values. They were just the really big pieces of cinnamon that stayed big the entire time. And so for that reason, we know that our data is going to be skewed, and we know that the mean is going to be larger than the median. And that's what we saw. We saw that the mean was larger than the median in this particular example. Because it's skewed, the median is probably the best bet. That 4 inches is a pretty good description of our cinnamon sticks, because half of the cinnamon sticks were lower than 4 and half of them were above 4. All right, that's all I've got for cooking this week. Maybe when I turn this off, I'll actually make some of that French toast. I will see you guys next time.